Okay. So here I can apply using the power rule here by pulling the 9 in front. So this would be 9 times log of p to the ninth. Just log of p. And then the 1/4 goes in front of log of n. And then minus the 5 goes in front of the log of m. Okay. So in this case here, that first line I had to apply the quotient rule by writing it as the difference of the individual logarithm. So it would be log of p to the ninth plus the fourth root of n minus log of m to the 5 to the fifth. Then for this first term I had to use the product rule by expanding as the sum of the individual logarithms, log of p to the ninth plus log of. Now for the fourth root of n, I changed that to n to the 1/4 power, writing it in its equivalent exponential form, minus log of m to the fifth. And then for each one of these, I use the power rule by pulling the exponent in front of the logarithm. So I end up with 9 times the log of p plus 1/4, and that should be a plus 1/4, by the way, 1/4 log of n minus 5 log of m. Are there any questions about problem number 21? Okay, problem number 22. Is a logarithmic equation. So here I have log to the base a of the quantity x plus 4 plus log to the base a of 6, and that's equal to log to the base a of 42. Now with that problem here, not only are you to solve that logarithmic equation, you are to check your proposed solutions on this to see if it satisfies the original equation. Okay, so the first thing you need to do here is condense each side as a single logarithm. Need to condense each side as a single logarithm. Look on the left side, we have a plus sign in between those two logarithms. That means I need to condense that using what rule? Well, here I got the sum of the individual logarithms. That can be condensed by using the product rule. So I can write this as a log of the product. So this will be log to the base a of, and what I'm going to do is put the 6 in front of the x plus 4, so it'll be 6 times the quantity x plus 4. And then that's equal to log to the base a of 42. And then I'm going to use what they call the one-to-one property. And of course the one-to-one property states this. Now I'll write this out to the side. If I have log to the base, let's say b of m is equal to log to the base b of n, then I can set m to be equal to n. So if I have the log to the same base on both sides, I can set each of those arguments equal to each other. So I can set that 6 times the quantity x plus 4 to be equal to the 42. And then we can solve this equation for x. So here, if I distribute the 6 over the x plus 4, I would get, let's say, 6x plus 24, and that's equal to 42. And then to solve this equation or get 6x by itself, I need to subtract 24 on both sides. So that means 6x is equal to 24 from 42. That's going to be 18. Divide both sides by 6, you'll get x is equal to 3. All right, now that's my proposed solution for this logarithmic equation. But of course, we have to check our proposed solutions here. Using the original equation, I'll replace each x with 3. So this will be log to the base a of x, which is 3, plus 4, plus log to the base a of 6, equals log to the base a of 42. Now if I add 3 plus 4, that's going to be 7, so this will be log to the base a of 7, plus log to the base a of 6, equaling to log to the base a of 42. Okay, and on the left side, I have the sum of the individual logarithms. I can condense that as the log of the product. So this will be log to the base a of 7 times 6. And of course, if I multiply 7 times 6, I would get 42. So I have log to the base a of 42 equaling to log to the base a of 42. Now I'll go no further than that because the left side does equal to the right side. So that means x equals 3 is the solution to that logarithmic equation. Are there any questions about problem number 22? All right, number 23 is another logarithmic equation where you have to solve and check your proposed solution. So here we got log to the base 6 of the quantity x plus 5 minus log to the base 6 of 7 is equal to 2. As you can see here, this one's a little bit different because where in number 22 you had the logarithm on both sides, in 23 you have the logarithm on only one side of the equation. So we'll start by condensing the left side as a single logarithm. Notice this time I have a minus sign in between the logarithms. So what rule can be applied here? Is it the product, the quotient, or the power rule? Quotient. Because the difference of the individual logarithms can be written as the log of the quotient. So this will be log to the base 6 of the x plus 5 goes in the numerator and the 7 goes in the denominator. And that will be equal to 2. Now, of course, we can write this in its equivalent exponential form. So if I had something like log to the base b of, let's say, m equaling to some constant, that is equivalent to saying this: b to the power of c equaling to m. So we can write this logarithmic equation in its equivalent exponential form. So in this case here, log to the base 6 of x plus 5 over 7 divided by 2 will be this. That 6 is your base. This 2 will be your exponent for the 6. So it'll be 6 to the second. Then that's equal to whatever this argument is right here, x plus 5 divided by 7. And then from here we can solve this equation for x. Now let's simplify what 6 to the second power is, or 6 squared. That's 36. And then that's going to be equal to x plus 5 divided by 7. And what I'm going to do is put that 36 over 1. Because what I'm going to do here is cross multiply, like this. So if I use cross multiplication here, I have 1 times the x plus 5, which will be x plus 5. And that's equal to 36 times 7 would be, what, 252? Yeah. So I have x plus 5 is equal to 252. And then to solve for x, I'm adding 5, so I need to subtract 5 on both sides. So that means x is equal to 247. So x equals 247 is the proposed solution for this logarithmic equation. But of course, we need to check our proposed solutions here. Using the original equation, I'm going to replace the x with 247. So it'll be log to the base 6 of 247 plus 5 minus log to the base 6 of 7 is equal to 2. And then if I add 247 and 5 together, I'll get 252. So it'll be log to the base 6 of 252 minus log to the base 6 of 7 is equal to 2. Now I have the difference of the individual logarithms, which condenses as the log of the quotient. So here I'm going to have log to the base 6 of 252 divided by 7. And that's equal to 2. Now if I take 252, divide that by 7, I would get 36. So log to the base 6 of 36 equals 2. And of course, if I convert that to its equivalent exponential form, that would be 6 squared equals 36. And then, of course, 6 squared is 36, so that checks. So that means x equals 247 is the solution to that logarithmic equation. All right, are there any questions about problem number 23? All right, number 24 and 25 are exponential equations. All right, number 24, we have 10 to the x minus 7, 10 to the power of x minus 7, and that's equal to 18. And here we want to solve this equation. For this variable, or just for x. And we're going to round the final answer to the nearest hundred, or to 2 decimal places. In this case here, you want to make sure that the exponential expression is by itself. Okay? And it is. Now, normally you'll take the natural logarithm on both sides. However, since we have a base of 10, it would be easier to take the common logarithm on both sides of this equation. So I'm taking the common logarithm on both sides of this equation. And I'm doing that because I know there's a property that states if I have log of 10 to whatever that exponent is, it's going to be that exponent. So if I take the log of 10 raised to the x minus 7, it would just be x minus 7. And then that's equal to log of 18. And now I can solve this equation for x. Since I'm subtracting 7, I'm going to add 7 to both sides. So here I'm going to have x is equal to, and if you want to, you can put the 7 in front of the log of 18, so it'll be 7 plus log of 18. Or you can say log of 18 plus 7. But let me warn you, when you enter this in the calculator, if you choose to put the log in first and then you type in 18, you want to make sure that you close your parentheses because you're only taking the log of 18. And then whatever that is, you'll add 7 to it. Okay? Or you can do like I have up here, type in the 7 and then plus log 18, close parentheses. Now the 2 decimal places to the nearest hundredth, that would be approximately 8.26. So x will be approximately 8.26. Okay. Are there any questions about problem number 24? All right, number 25. And I'll do that over here. And it's another exponential equation, 2 to the 2x minus 1 equals 32. 2 to the 2x minus 1 equals 32. Well, in this case, you want to express each side with the same base. So here I got the 2 here, so I need to write 32 as 2 to some power. So if I go up to the side here and divide 2 into 32, 2 goes into 32 16 times, 2 goes into 16 8 times, 2 goes into 8 4 times, 2 goes into 4 2 times, 2 goes into itself 1 time. How many factors of 2 do I have here? 5. So 32 can be written as 2 to the 5th power. Okay? Bless you. Also, I see here that my bases are the same. So there is a rule that says here, if you have b to the power of m equaling to b to the power of n, then m equals n. That means I can set my exponents equal to each other. Since these bases are the same, I can set the 2x minus 1 to be equal to that exponent of 5. So here I have the equation 2x minus 1 equals 5. And then I can solve for x. Well, first of all, I'm subtracting 1, so I need to add 1 to both sides. So that means 2x is equal to 5 plus 1, that's 6. And then to get x by itself, divide both sides by 2, you'll get x is equal to 3. Now with these exponential equations, you don't need to do the check if you want to, or unless you want to. So here, that'd be x is equal to 3. All right, questions on number 25. Okay. All right, number 26 is a compound interest problem. Okay. And it states here, how long will it take for $5,000 to grow to $7,500 if the principal was invested at 7% annual rate interest compounded continuously? And round your answer to the nearest tenth or to one decimal place. All right, so here's what we have. We have a $5,000 investment. So this is what P is, $5,000. We want that to reach $7,500. And the principal is being invested at a 7% annual rate interest. So R is 7%. And what's 7% as a decimal? Has to be 0.07. Drop the percent sign, divide by 100 since percent means per 100. Okay, so now we're looking for the time that it's going to take for that investment to reach that amount. So in this case here, we're going to use, and it's compounded continuously, so we must use this formula. A is equal to P times e to the RT. Okay, it says compounded continuously, so we must use that formula. A is equal to P times e to the RT. Now let's substitute into this formula. Your A is $7,500. That's equal to P, which is $5,000, times E to the R, that's 0.07, times T. So that's our exponential equation that we will use here. Now we need to get the exponential part by itself, that e to the 0.07t. It's being multiplied by 5,000, so let's divide both sides of this equation by 5,000. So here if I do 7,500 divided by 5,000, that will be 1.5. And then the 5,000s divide out, you'll be left with e to the 0.07t. All right, now since e and ln are inverses of each other, it'll be best to take the natural logarithm on both sides of this equation. So when I do that, the left side will still be the natural log of 1.5. Then that's equal to ln of e to the 0.07t. If I have ln of e to whatever my exponent is, it's going to be that exponent. So ln of e to the 0.07t will be 0.07t. And then to solve for t, I'll just go ahead and divide by 0.07 on both sides. So here, we use our graphing calculator. Then in this case here, we'll type in the ln, or press the ln key, and then 1.5, close parentheses, divided by 0.07. And then hit enter. And to one decimal place, that amount would be what? 5.8. And our time is in years, so that means it's going to take approximately 5.8 years for a $5,000 investment to reach $7,500 at 7% compounded continuously. Okay. Are there any questions about problem number 26? All right, number 27 is solving a system of equations in 3 variables. So here we got 5x plus 6y minus 2z. And that's equal to 2. And then 2x minus y plus z is equal to 2. And x plus 4y minus 2z equal 0. And here we're going to solve this system of equations in 3 variables. So this was section 5.2. And the way we do that is first I'm going to label the first equation, equation 1. The second one would be equation 2. The third one would be equation 3. And I'm going to pick 2 pairs of equations and eliminate the same variable. That way I have 2 equations and 2 variables. All right, let's see here. I'm going to start with, let's say, equation 1 and equation 2. 5x plus 6y minus 2z is equal to 2. Equation 2 is 2x minus y plus z is equal to 2. Let's see here. I could eliminate either the x or the y or the z. Let's see. I'm going to try to eliminate the z in equations 1 and 2. Because notice I have a minus sign and a plus sign here. I could eliminate the y if I wanted to, but I'm going to eliminate the z here. If I want this plus z to be a plus 2z, I need to multiply that second equation by 2. So the first equation stays the same. The second equation, I'll do 2 times 2x, that's 4x. 2 times the minus y will be a minus 2y. And then plus 2 times z, that would be plus 2z, equals 2 times 2, which is 4. And then add the 2 equations together. So 5x and 4x, that's going to be 9x. 6y minus 2y will be a plus 4y. The 2z's add to 0, minus 2z and plus 2z, equals 2 plus 4, that's going to be 6. So that 9x plus 4y equal to 6 represents equation 4. I'm going to label that as equation 4. All right, now I'm going to pick another pair of equations, but I have to eliminate the z since I eliminate the z in equations 1 and 2. Well, let's use 2 and 3. In equation 2, that's 2x minus y plus z is equal to 2. Then equation 3, I got x plus 4y minus 2z is equal to 0. So in equations 2 and 3, I'm going to eliminate the z as well. Well, let's see here. I got a plus z and a minus z here. If I want this z to be 2z, I need to multiply that second equation by 2. And when I do that, that second equation will be this. 2 times 2x, that's 4x, minus 2 times y, that's 2y, plus 2 times z, that's 2z, equals 2 times 2, which is 4. Then I'll rewrite equation 3, x plus 4y minus 2z equals 0. Now let's add the 2 equations together. 4x plus a 1x, that's 5x. Negative 2y plus 4y will be a plus 2y. 2z and negative 2z add to 0. And that's equal to 4 plus 0, which is 4. So here I've got 5x plus 2y equals 4. That's going to be equation 5. And now I'm going to use equations 4 and 5 to eliminate either the x or the y. So equation 4 was 9x plus 4y is equal to 6. Equation 5, that's 5x plus 2y, is equal to 4. All right, so which variable would you like to eliminate, the x or the y? The y, because I know 4 is a multiple of 2. If I want that 2y to be, and I do need opposite signs here, so I need to multiply the second equation, equation 5, by what number? Negative 2. So here we got 9x plus 4y is equal to 6. And now for the equation 5, negative 2 times 5x, that's negative 10x. Negative 2 times plus 2y would be minus 4y. That's equal to negative 2 times 4, negative 8. And now we can go ahead and add those two equations together. 9x plus negative 10x will be a negative, I'll say negative 1x here. 4y and minus 4y adds to 0. That's equal to 6 plus negative 8, which is negative 2. So I got negative 1x equal to negative 2. And if I divide both sides of this equation by negative 1, I'm going to get x is equal to 2. So x equals 2. We know what that is. Now I need to find out what y is and what z is. Well, let's use equation 4 or equation 5 since it's in two variables. And I know the value of one of the variables is. So if I use equation 4, which is in this case 9x plus 4y equal to 6, I will replace that x with the 2. So it'd be 9 times x, which is 2, plus 4y equal to 6. And then now 9 times 2, that's 18, plus 4y equaling to 6. Subtract 18 on both sides, you'll get 4y is equal to 6 minus 18, that's negative 12. And then to solve for y, we'll divide both sides by 4. That means y is equal to negative 3. So now I know what x is, I know what y is, now I need to find out what z is. I could use one of the 3 original equations that I started off with and substitute the x with 2 and the y with negative 3. Now, here I'm going to use equation 3. X plus 4y minus 2z equal to 0. So here I'm going to substitute the x with 2. So it'll be 2 plus 4 times, replace the y with negative 3, minus 2z equal to 0. Okay. So I have 2. 4 times the negative 3 will be minus 12. Minus 2z is equal to 0. And then if I do 2 minus 12, that's going to be negative 10. So it'll be negative 10 minus 2z equal to 0. And then to get negative 2z by itself, I have to add 10 on both sides. So here we got negative 2z is equal to 10. Then finally divide both sides by negative 2. You'll get z is equal to negative 5. So here I know what x is, I have what y is, and what z is. So the ordered triple solution for this system of equations in three variables will be this: 2, negative 3, negative 5. 2, negative 3, negative 5. Are there any questions about problem number 27? All right, problem number 28 is a nonlinear system of equations. Here you're going to solve that using the substitution method. So in this case here, number 28 is this: x plus y is equal to 3. And then the second equation is y is equal to x squared minus 6x plus 9. All right, so here I'm going to write these two equations side by side. X plus y is equal to 3 here, and the other x squared minus 6x, y is equal to x squared minus 6x plus 9. Now, as you can see here, I've already got y equal to something, and that's the x squared minus 6x plus 9. Since y is equal to that, let's take that expression, which is what y is equal to, and substitute it for this y in the first equation, and solve. So on the left side, I bring down the x, substitute this y with that x squared minus 6x plus 9. And then that's equal to 3. And then next I'll combine some like terms here and put these terms in descending power. So I'm going to put the x squared first. 1x minus 6x will be minus 5x. So I get x squared minus 5x, and then plus 9 is equal to 3. Now I have a quadratic equation, which means I need to get a 0 on one side of this equation. That means I need to move the 3 over to where x squared minus 5x plus 9 is. Now I'm going to do that by subtracting 3 on both sides. So here I get x squared minus 5x. 9 minus 3 will be 6, so it'll be plus 6, equal to 0. Now on the left side, it is I do have a quadratic equation, so on the left side, I need to factor into two binomials. Let's factor x squared minus 5x plus 6 into two binomials, if we can. So x squared breaks up as x and x, and then what factors of 6 will give me negative 5x as a middle term? Minus 2 and a minus 3. They both have to be negative since the middle term is a minus, the last term is a plus. So I get x minus 2 times x minus 3 equal to 0. And then we set each binomial factor equal to 0. So this means x minus 2 is equal to 0. X minus 3 is equal to 0. And for each equation, we'll solve for x. So for the x minus 2 equal to 0, that means x will have to be equal to 2. And then for the x minus 3 equal to 0, x must be equal to 3. So here we got x equals 2 and x equals 3. Now for each x value, I need to find out what y is. All right, so let's start off with the x equals 2. And I could use either one of these two equations here. Let me go ahead and use that first equation, x plus y equals 3. I believe that's the easier one to use here. And just replace the x with 2. So this will be 2 plus y is equal to 3. And then to get y by itself, we'll subtract 2. That means y has to be equal to 1. So for x equals 2, y has to be equal to 1. So that's one ordered pair, 2, 1. Now the ordered pair when x is equal to 3. I'll still go ahead and use that x plus y equals 3. And substitute that x with the 3. So it'll be 3 plus y is equal to 3. And if I subtract 3 on both sides, y will be equal to 0. So when x is 3, my y value will be 0. So these are my two ordered pairs for this system of equations. 2, 1 and 3, 0. Those are the ordered pairs that will satisfy that system of equations. All right, any questions about problem number 28? All right, number 29 is using the addition method for this system of nonlinear equations. So here we got 4x squared minus 3y squared equals negative 11. And then the other equation is 5x squared plus 2y squared is equal to 38. And here I want to solve this nonlinear system of equations here. Well, I know I need to eliminate either the x squared or the y squared. It'd be best to eliminate the y squared since I have opposite signs already. Now I have a 3 and a 2 as my y coefficients. So what would be a least common multiple for 3 and 2? It's 6. That's the smallest number that's divisible by 2 and by 3, which will be 6. So for the first equation, 4x squared minus 3y squared equals negative 11. If I want that minus 3y squared to become minus 6y squared, I need to multiply that equation by what number? By 2. And for the second equation, if I want that 2y squared to be 6y squared, I need to multiply that equation by 3. All right, so when I do that, that first equation being multiplied by 2, I have 2 times 4x squared, that's 8x squared, minus 2 times 3y squared will be 6y squared, equals 2 times negative 11, that's negative 22. And now for the second equation, I'm multiplying it by 3, so 3 times 5x squared would be 15x squared. 3 times the plus 2y squared would be a plus 6y squared. That's equal to 3 times 38, which is 114. Now we're going to add those two equations together. So here, 8x squared plus 15x squared will be 23x squared. The minus 6y squared and the plus 6y squared add to 0. And then that's equal to negative 22 plus 114 would be 92. So I got 23x squared is equal to 92. And now to get x squared by itself, I'm multiplying it by 23, so I need to divide both sides by 23. So here x squared is equal to 92 divided by 23 will be 4. And now, to find out what x is, what's the opposite of squaring something? Take the square root on both sides. And of course, you have to include that plus or minus symbol if you take the square root on both sides of an equation. So the square root of x squared is x, equals plus or minus the square root of 4 is 2. So here x will be equal to 2. And that, of course, means x is equal to 2, x equal negative 2. And for each x value, we need to find out what y is using one of the two original equations that we started off with. So I'll start off with the x equals 2 first. And I'll go ahead and use the second equation here, which is that 5x squared plus 2y squared equals 38. And replace that x with the 2. So here I'm going to have 5 times x, which is 2, that's squared, plus 2y squared equals 38. All right, if I square this 2, that's going to be 2 times 2, which is 4. 4 times the 5 in front, that would be 20. So I got 20 plus 2y squared. (20 plus 2y squared) is equal to 38. And then to get that 2y squared by itself, I need to first subtract 20 on both sides. So that means I have 2y squared is equal to 18. Then divide both sides by 2. Y squared is equal to 9. And then the opposite of squaring something will be to take the square root and include the plus or minus symbol. So y would be equal to plus or minus 3. So for x equals 2, I have y is equal to 3. And also for x equals 2, I have negative 3. So here I got the two of my ordered pairs, 2, 3, and 2, negative 3. Now what about for x is equal to negative 2? I'm going to use this same equation, 5x squared plus 2y squared is equal to 38. Replace the x with negative 2, so it'll be 5 times negative 2, and that's squared, plus 2y squared equals 38. If I square the negative 2, that's negative 2 times negative 2, that's positive 4 times the 5 in front, that'd be 20, plus 2y squared, and that's equal to 38. And pretty much I can stop right here because that equation is the same as this equation here, so if I go through that, I'll still get y equal plus or minus 3. So for x equal negative 2, one y value will be 3, and for the negative 2, the other y value will be negative 3. So these are the 4 ordered pairs that will satisfy that nonlinear system of equations, 2, 3, 2, negative 3, negative 2, 3, and negative 2, negative 3. Are there any questions about problem number 29? And finally, problem number 30 is graphing a system of inequalities. Here we got 3x minus 4. Y is less than or equal to 12. The other equation is 3x minus 2y is greater than 6. And here I'm going to graph this system of inequalities on a coordinate plane. And on the final exam, you will have a coordinate grid to graph those inequalities. Because in this case here, you want to shade in the part that satisfies both of these. All right, so the first thing I'm going to do here is I'm going to deal with the 3x minus 4y is less than or equal to 12. We graph each one of these individually on the same coordinate plane. And I'm going to treat this as 3x minus 4y equals to 12. Because here I want to find what that graph is going to look like. Okay. Now since x and y are on both sides, I'm going to use intercepts, like the x-intercept. Here I'll let y equal 0 and solve for x. Anytime you're finding the x-intercept, you want to let y equal 0 and solve the equation for x. So I'm going to substitute the y in that equation with 0. So it'll be 3x minus 4 times y, which is 0, and that's equal to 12. Here 4 times 0 is 0, so you'll be left with 3x equals to 12. And if 3x is equal to 12, what must x have to be equal to? 4. So my x-intercept is the ordered pair for 0. And then we're going to find the y-intercept. To find the y-intercept, you let x equal 0 and solve for y. So I'm going to substitute 0 in for y into this equation here. So it'll be 3 times x, which is 0, minus 4y is equal to 12. Well, 3 times 0 is 0, so you're left with negative 4y is equal to 12. Divide both sides by negative 4, you'll get y is equal to negative 3. So negative 3, 0 is the, 0, negative 3. I'm letting x equals 0. Sorry. X is 0, and y is negative 3. All right, so now let's go ahead and graph this on the coordinate plane. My x-intercept there is 4, 0. My y-intercept is 0, negative 3. That's going to be this point down here. Now, based on that inequality, will that line be a solid line or a dashed line? Solid, because it says less than or equal to. That means that the line itself will be included. Okay. Now, I need to determine which side do I need to shade. So what I'm going to do here is select a test point. And whenever possible, a good test point would be the ordered pair 0, 0. Just so long as that line, that point is not on the line. So a good test point would be right here, 0, 0. And then we substitute the x with 0 and the y with 0 in this inequality to see if it's true or false. So we got 3 times x, which is 0, minus 4 times y, which is 0. The left side must be less than 12. 3 times 0 is 0, minus 4 times 0 is 0. 0 from 0 is 0. Is 0 less than 12? Yes. So here's what we're going to do. We're going to shade the part where the test point is included. So I'm going to be shading up here above this line. And that includes the test point. Now I need to graph the second equation 3x minus 2y is greater than 6. All right, so here I'm going to treat this as 3x minus 2y equals to 6. And in this case, I'm going to find their x and y intercepts as well. So here's what we got. Let's see, I'll use this color. So for the x-intercept, we let y equal 0. So that means I'm going to have 3x minus 2 times y, which is 0, and that's going to be equal to 6. Well, 2 times 0 is 0, so that means that 3x has to be equal to 6, and x has to be equal to what? Has to be equal to 2. So it'll be 2, 0 for the x-intercept. And then for your y-intercept, we let x equal 0. So it'll be 3 times 0 minus 2y is equal to 6. Well, 3 times 0 is 0, so we're left with negative 2y is equal to 6. That means y must be equal to what? Negative 3. So 0, negative 3 is my other y-intercept for that line. All right, so two 0 is here. 0, negative 3 is down here. Now, would this line be solid or broken? This time, broken, because it's strictly greater than. So in this case here, I'm going to be drawing a dashed line or a broken line or a dotted line, whichever you like to call it, because that's showing that this line will not be included in that solution set. And now I need a test point. Again, I'll use 0, 0, since that point is not on that line. And then just replace the x and the y with 0. So this will be 3 times 0 minus 2 times y, which is 0. That needs to be greater than 6. 3 times 0 is 0, minus 2 times 0 is 0. 0 minus 0 is 0. Is 0 greater than 6? No. So that's a false statement. So I'm going to be shading the region that doesn't contain this test point. That means past this line right here to the right is what I'll be shading. Okay. Now, let's find the intersection of these two lines here, of those two shadings. If you look at it, where I have the blue and the green together, that's going to be this part right here. So I'm going to shade this part right here. That's the shaded area, or the intersection of the two. That shaded region is that region that satisfies those two inequalities here. All right. Are there any questions about problem number 30? Or are there any questions about what is expected to be on the final exam?